We learned how to add two different vectors together. We learned how to subtract two vectors, and we learned how to multiply a scalar or a number times a vector. In this video, we're going to learn about one way in which we can multiply two vectors together, and that is called the dot product. So, before we actually get to doing that, let's talk about length here. They are going to be closely related. So if you want to find length of a vector and you're working in two dimensions, R2 here, it's just the square root of x squared plus y squared. That's the result of just doing a Pythagorean theorem that everyone's familiar with. In R3, it's slightly more complicated. It's the square root of x squared plus y squared plus z squared. Turns out this is also a consequence of Pythagorean theorem if you do it in three dimensions, but regardless, those are the formulas we have for finding length. Let's take a look at this simple example here. Find the length of this vector. So we just apply the formula, the square root 1 squared plus 3 squared plus negative 2 squared is 1 plus 9 plus 4 is the square root of 14. So that right there is the length of this vector, how long it is. The next definition here is what a unit vector is. A unit vector is any vector whose length is 1. Now we just calculate this length to be square root of 14, which means that vector is not a unit vector. However, there are many applications in formulas in future classes, including in calculus, where you need to be able to have a unit vector, otherwise you'd be changing your answer there. And so what we'd like to do is we'd like to find a unit vector that is in the same direction as this vector here. So we want it to have the same direction. We don't want to change the direction. We just want it to only be length 1. And it turns out that's actually really straightforward. You just take your vector, you divide by the length, and the resulting vector here is going to be a unit vector. And you can double check that by finding the length using the formula for this new vector here, and the length will be 1. Okay, so that's the idea of length of a vector, either in R2 or R3. Now we can finally talk about the dot product, our way of multiplying two vectors together in some sense. And so what we're going to have here is if you want to multiply two vectors in R2, you multiply the first components together, then you multiply the second components together, and then you add them up. So x1 times x2 plus y1 times y2. If you're doing it in three dimensions, you just add the z coordinates on there. So as our example here, we're trying to find the dot product. We multiply first number times first number, second number times second number, and we always add the results. I see a lot of students make a mistake and subtract there because they're thinking of the determinant rule, and this is something completely separate from that. So we go ahead and work this out here. It's going to be 3 minus 15 is a negative 12. So that number right there is the dot product of those two vectors. Now I do want to point out something here. I want to point out that even though we started with two vectors and we multiply them, when we do the dot product, the answer is actually going to be a scalar or just a number here, right? This answer is not a vector itself. That's kind of one of the important features of the dot product. And as a result, what we can do is we can just using the formula here, that if you take a vector and dot product with itself and square root it, that's the same as the length of the vector. So what I'm trying to get at here is that if you know what dot product is, you can then find the length using the dot product. On the other hand, we normally get length in R2 and R3 by just using Pythagorean theorem. But what we're going to see in the future video is we're going to find length in really, really weird situations. For example, what if my vector is a function? We're going to say what the length of a function is. And you probably don't see how to apply Pythagorean theorem when you're talking about functions instead of points. So we're going to see all of that's going to come down to this formula here that says that the length is the same thing as the square root of a vector dot product with itself. Okay. Now this next one up here, this is also another important formula. It gives us a way to calculate the angle between two vectors. So if you have some vector x in this direction and some vector y in this direction, we don't care how long they are here, and you have this angle theta that's between them, well, you are guaranteed that cosine of theta is going to equal x dot y divided by the length of x times the length of y. So we can calculate everything on the right hand side here. We've learned how to do that. And then we put it in our calculator, do cosine inverse, and that will tell us the angle between two vectors. So let's go ahead and do that here with these two vectors here. We know what the dot product is already. We worked that out earlier. It's negative 12. So now I need the length of each one of these vectors. The length of 1, 5. The square root of 1 plus 25 is square root of 26. Then I need to go ahead and do the length of 2, negative 3. Square root of 4 plus 9 is square root of 13. Then we go ahead and put our formula here. Cosine theta is the dot product divided by the two lengths multiplied with each other. And if we go ahead and type it in our calculator and do cosine inverse of all of that, do make sure you include the negative sign. Also make sure that you are multiplying those two square roots in the denominator. If you don't use your parentheses correctly, you won't get the right answer here. And so one last thing is, it doesn't really matter which you use, degrees or radians, but make sure you know which one you are using. In this case, if I use degrees, I get 130.7 degrees. And so that means that if I have one vector here, it's going to be at 130 degrees, something like that. So it gives a really nice, useful way of finding the angle between these vectors. I'm definitely not an expert in chemistry, but I do remember in chemistry class we had to do this exact formula to find the angle between some hydrogen atoms in some sort of molecule, and it turned out that the angle you got, what value it had, would change the chemical properties of the material. So sure, we're just in math class doing this seemingly pointless, but this stuff does actually matter, right? Again, the way that things work in chemistry will depend on the angle you get here. Anyways, this last comment here is, if you look at this here, what happens if you're 90 degrees or perpendicular? And by the way, just to make things more confusing, we came up with another name for perpendicular. We call it orthogonal here. And the only time that's going to happen, if you look at that formula, is if the dot product equals 0. So if you ever have two vectors and you calculate dot product, if you get 0, then that means they're perpendicular. And if you don't get 0, that means they are not perpendicular.